We don't want to, probably we feel all saturated. So still we have three lecturers here, and things you wanted to ask, but you didn't. You can always come and ask questions. All right, come on guys, ask questions. Come on down and anybody.
So by using, in terms of y function, you rewrote the quantization condition, but I didn't quite get, so what is the advantage of using y function? Then what is, what was new?
Okay, so the advantage is that y's you can actually compute using the function equation that I derived and also the integral equation. And that's the kind of simplest thing that you can get from this formalism. And you want to state the quantization condition using those variables. And that was basically the thing that I explained. So rewriting the quantization condition using y functions. But you should remember that it's not so easy to just like looking at the double well Schrödinger equation and then try to determine the quantization condition. But this wise basically you can like easily solve it by solving the TBA, the functional equation or integral equation that I wrote, and it actually converges very fast because everything exponentially suppressed in the small h bar limit. So it's just like a rewriting the condition using the easy to compute variable.
Okay, thank you.
In your lecture, you mentioned actually a global symmetry can be viewed as a gauge symmetry with zero coupling. Is that true? So maybe it's well known, but how do I understand that fact?
Well, you could think of you think about the kinetic term for the gauge field, for instance.
Oh.
If you
that's
send,
for everybody. So
if you send a gauge coupling to zero, then it becomes not a dynamical field. So that's one way to see it.
Okay, thank you.
If there are no more questions, then I think we should all thank Kim Young and all the organizers for a really impressive school, very interesting, very well organized, very enjoyable. So thank you.